Good morning, everyone, and welcome to Sterling's VMC on AWS demo. I am Mindy Schweitzer, Director of Marketing for Sterling. We know your time is valuable, so we want to thank you for choosing to spend a portion of your day with us. Before we dive into the demo, I wanted to give you a brief overview of Sterling's capabilities. Sterling is a technology solution provider offering secured, customized solutions for all your clients' cloud needs. We serve on multiple federal and state and local government contracts and support all industry verticals. Security is of the utmost importance at Sterling. We have a robust, secure supply chain, including OTIPs and CMMC certifications. For any questions about Sterling, please use the email aliases that you will find at the end of the demo. For questions during the demo, please put them into the Q&A feature at the bottom of your screen, and we will address them at the end. Now I will turn it over to Cloud Architect Billy Downing to demonstrate VMC on AWS. Thank you, Billy.
Awesome. Thank you, Mandy. Can you hear me okay? I just want to make sure that I was having issues with Zoom a second ago.
Yep, you sound great.
Okay, perfect. So thank you for the introduction. My name is Billy Downing. I'm a Cloud Architect here at Sterling. And today we're going to talk about VMC or VMware Cloud on AWS, what that solution looks like, and how you can use it to your advantage if you have a cloud migration strategy in place, or some other solutions you might want to look at incorporating VMware on cloud solutions. So first, we'll take a look at the VMware Cloud offering. So we'll take a look at what is the basis of VMC and AWS, or what are those fundamental building blocks. So we'll be looking at VMware Cloud Foundation, which a lot of you are probably familiar with as the on-premises solution for private cloud from VMware. We'll take a look at VMware HCX and how that tool allows us to bridge our on-prem environment into VMC on AWS or other environments as well, to enable a hybrid cloud environment or enable a workload migration type of setup that we'll be demonstrating later on. Then we'll kind of discuss a little bit about the different solutions or use cases that people have used for VMC and AWS and how those might relate to you and just other directions you can take using this type of a service. And finally, we'll end it off. We'll actually go through the UI and we'll take a look at an environment that I have in the Solution Center, which is a VMware Cloud Foundation on VxRail environment. And it's connected to a 2-node cluster in VMC on AWS through HCX. So I'll show you what that looks like, what kind of components go into building that, and then what are the results of that? How does it actually provide value to your cloud migration strategy? Okay, so for starters, we'll talk about what is the VMware Cloud Foundation, and essentially what this is are the building blocks for a VMware envisioned or VMware opinionated and prescripted software-defined data center. So what this provides you with is vSphere for compute, for virtualization as a platform. And in more recent iterations, that also provides you as a container platform as well, using vSphere with Tanzu. So you have a compute platform that is abstracted from the hardware that allows you to run virtual machines or containers however your applications dictate. We also have vSAN for software-defined storage. So that's going to be a disaggregated and distributed storage cluster built on top of your same compute nodes using a shared storage model. So what that's going to do is provide you with a hyper-converged environment where your compute nodes and your storage nodes are one and the same, and you have a single management pane to go ahead and take care of each one of those. And because they each have context into one another, for example, vSAN is built into vSphere just as much as vSphere is built into vSAN. You get a lot of benefit from an observability perspective as well as a data manipulation perspective. The final step or the core component that makes up VMware Cloud Foundation is that software-defined network. And for that, we're going to be looking at NSXT. And that's going to be the foundation for our network fabric. And it's going to be what provides us the ability to not only provision workloads on top of our compute infrastructure, store those workloads in vSAN, but also provide the overall plumbing between nodes as well as ingress and egress from our environment using NSXT. All of these tools are driven by their various APIs, so everything can be automated, and you can start using, thinking of VMware Cloud Foundation or VMware Cloud in general as another endpoint to run your resources wherever they live. The final step for VMware Cloud Foundation is the orchestration layer. So that is going to be the SDDC manager perspective of this. And essentially what that's going to do is sit above the vCenter or sit above the single cluster orchestration level and just manage all your workload domains wherever they live. So that can be a way that you can federate clusters across multiple sites if you have multiple on-premises locations, and so on and so forth, help you with lifecycle and things like that. So the point of this is these components are something that a lot of VMware engineers are familiar with today. These are a lot of components, whether they're used individually or all in tandem in a VCF type environment. But these are things that VMware engineers are very familiar with, know how to troubleshoot, know how to design for, and know how to run workloads on top of. So oftentimes an issue with migrating to the cloud or an issue with the thought of planning a migration strategy into something like AWS or GCP or Azure is that you're unsure of how to create an entirely new environment to fit your application, or you have your applications fine-tuned to run on your VCF environment. What does that look like when you move into the cloud? And if you're running to the cloud natively, that also means you're going to be converting VMDKs into EC2 instances. You're going to be creating AMIs. You're going to be managing your own VPCs and routes and subnets and all the things that go along with that. There's nothing inherently bad about that, but there is a quite large gap between your on-premises environment and functionality into the cloud, which requires you to do pretty in-depth planning to fill that gap during that migration process. So what VMware Cloud on AWS is providing is the ability to go ahead and take all of that knowledge that you already have for your VMware on-premises environment, all of those different formats and things that you're running in your environment today, so you know what's supported, what isn't, what style of management is necessary and what isn't. And you can take that and migrate it directly into AWS. So you can offload your responsibility of managing a data center, offload your responsibility of managing the overhead of the different components that make up your software-defined data center, and move that into a VMware managed service using AWS infrastructure. So you're offloading all of that management, you're offloading the physical requirement for your own data center, and you're also introducing a new set of SLAs for your environment that you can hold accountable on behalf of VMware and AWS in tandem. So essentially what this is, VCF is the foundation of the components that make up VMware VMC on AWS. And so again, all of those components are going to be built in an SCDC in AWS on top of AWS bare metal nodes. And those are going to be managed by VMware. So you still have one entity of support to contact when you have issues, but it gives you the ability to just offload that from a hardware and management perspective onto the vendor that develops a solution itself. So now we have all of our components as we're mapping out this VMC and AWS environment and what it actually looks like. We have all of our VCF components, and we're going to automate the deployment of that into AWS. So we have an as a service type model. So for example, I have a 2-node VMC instance in AWS. If tomorrow my burst or I have some sort of application that is very bursty or some sort of need for additional resources, I don't have to go through an entire procurement process for new servers and then add the servers into a cluster and rack and stack them and provide power and cooling and all that stuff. What I have to do is really just go to VMC, go to my portal, my self-service VMware Cloud portal, add a node to my cluster. In about 15 minutes, I'll have that node added. It's all based on consumption. So I'm only paying for exactly what I need to use at the time that I'm using it. Say if I've just added a new node into my cluster, a new bare metal EC2 instance or AWS EC2 instance into my cluster, a week later that demand drives down, I can go ahead and remove that. And then I'm no longer paying for that bare metal instance running in my software-defined data center at that point. So that gives me the ability of elasticity within AWS Cloud. So it brings some of those benefits, those AWS native benefits and services that you would think of as in a public cloud environment, and brings them into your VMware environment. So you're kind of meshing the two methodologies of application and infrastructure management from the vSphere perspective and the AWS perspective as well. So because all of these, this SCDC that you're running the VMware stack on top of is in fact in a VPC located in AWS, you also have the ability to peer that VPC with additional VPCs within AWS to consume native services. So say if you have a long-term migration strategy into the cloud, and say, for example, today you're managing a lot of databases. Well, database administration can become quite difficult over time, lifecycle management, all of that good stuff, and it requires specialized staff more often than not. Well, AWS offers a service in RDS that you're allowed to use as a managed database service, and AWS will then take care of that lifecycle management and all of the different components that goes along with it. So what you can do is after you migrate some of your instances into VMC and AWS, because you are already in the public cloud, now you can start connecting your virtual machines into AWS native services like EFS, like RDS, and other instances that you can start consuming to advance the capability of your applications. For example, if you have some sort of need for machine learning, you can start utilizing different streams of AWS services directly from your VMware data center located in the cloud. Those are just some of the benefits you get for having that VMware built environment just sitting adjacent to all the AWS native services that you can use to enhance your application capabilities. And finally, to tie all this together, when you're talking about VMC and AWS specifically, we have our VMware Cloud Console, which is very similar if you think about the AWS Cloud Console, where you go to this single console to enact all of your different services, invoke new resource utilization, or whatever the case may be. You have the same concept within VMware Cloud, and we'll take a look at what that looks like and how we can use that. But it really gives us very similar to how SCDC Manager gives us that overall orchestration of our on-premises VCF environments. The VMware Cloud Console gives us a similar functionality within all of our instances that are located in VMC on AWS. So we can stand up multiple SCDCs if needed. We can connect all those SCDCs up together using groups, and we can go ahead and build out all of our network policy through NSX, all through a single pane of glass in our VMware Cloud Console. I'm gonna take a look at all of that once we jump into the actual environment and make a little more sense, I think. So now, how are we going to actually connect our environments? And the use case that I'm going to be demonstrating today is if I were doing some sort of a hybrid connection between my on-premises VMware Cloud Foundation environment and my VMware Cloud on AWS 2-node cluster. There are several ways to do that. You can connect it through Direct Connect. You can use VPN connections, but you can also use HCX if you're trying to migrate workloads easily across multiple environments. So HCX initially is an any-to-any migration or mobility platform by VMware that provides an abstracted tunnel between your on-premises environment into your VMC on AWS environment. It's not specific to on-premises to cloud. It can be from a VMC to VMC, like two separate clusters in different regions. It can be from a on-premises environment to another on-premises environment if you're looking just to migrate workloads across different uses. So this tool isn't specific to the use case that I'm using it, but this is a very common use case for VMware HCX. And really what it does is gives me that overarching network connectivity between my environment A and environment B. And it allows me to not only migrate my workloads in a bulk type fashion, like a cold migration. Not only does it give me that capability to go ahead and migrate 100 virtual machines into the cloud at once in a cold migration, but it also gives me the ability to do hot migrations using vMotion and replication assisted vMotion. So what I can do is schedule vMotions into the cloud. And if I have an application that is extremely sensitive to outages or latency or IP changes or things like that, HCX also provides me the ability to go ahead and stretch layer 2 segments from my on-prem environment into the VMC on AWS environment. So what that's going to do is, and we're going to look at this in a second, when I actually migrate a workload from my on-premises environment into the cloud, I don't have any sort of VPN for this setup, and this is specifically to highlight the capability of HCX. But once I do that, I'm going to hold a ping to that IP address that I have on-prem, and because HCX is actually extending that layer 2 segment into the cloud, it creates all those instances and all those segments in NSXT in my VMC environment. And we'll see that I only drop a few pings because the actual traffic flow of the virtual machine I'll be migrating in this hybrid cloud setup is still going to traverse the HCX tunnel into my on-prem environment for ingress and egress. So what that means is that I don't have to change IP addresses. I don't have to change MAC addresses or anything like that. It'll give me a way to go ahead and extend my subnets into the cloud, migrate workloads into the cloud, and then if I kill that tunnel, I can move the gateway into VMC and AWS to complete that migration, or leave it long-standing in a little more of a, if you were to have it for a long-standing solution where you wanted a hybrid cloud, you would probably look at something like Direct Connect or VPN connectivity between your different sites. So looking at a few different solutions that are very common for a lot of individuals that we talk with VMC about for different problems they're trying to solve. The first one, and then probably the most obvious, is data center migration. So I talked about this earlier from the perspective of migrating native vSphere on-premises data centers into AWS can be a daunting task. It requires skill acquisition. It requires extensive planning and understanding AWS and its services and how they might differently react with your applications. And again, I'm not saying that that's a bad approach. That's, that's the way that a majority of people will do it. But VMC just offers a different solution that if you are invested heavily into the vSphere environment, or you just really like how vSphere is interacting with your applications, which is oftentimes the case as vSphere is dedicated to certain types of applications, and there's very a lot of performance enhancements and things like that. You have that data center migration option. So you can migrate to off your on-premises data center. You can get out of the business of managing data center objects. You can go ahead and offload that to AWS and VMware in tandem and easily migrate your workloads into AWS without having to refactor any sort of applications. The second one is cloud VDI. So this is kind of in light of the entire pandemic that's gone across the entire world. Is that a lot of our customers are doing a lot more work from home type environments. And so what that means is that you have to find a way to efficiently and with scale provide that service for your end customers or your whoever's at your company or whatever, whoever you're providing that service for. So a lot of times that requires you have to spin up new resources. So if you were doing this in an on-premises environment and you want to provide Horizon VDI to your entire organization overnight, it would be quite difficult to enable your existing compute clusters that perhaps were built for the capacity they were planned for, and this is an unplanned capacity addition. So you'd have to go through the process of acquisition for procurement of hardware, install it, and do all that case and get Horizon up and running. And then you're still bottlenecked by your single company, your company's internet connection for everybody connecting into their Horizon environment. So what this does is give you a quick way to, if you're just trying to test out services, or you want to be able to not have to add any more compute into your existing infrastructure, maybe you don't have enough space for it, not enough cooling or electricity, you can go ahead and stand up an SCDC in VMC and AWS, build Horizon on top of it, and within a few hours, you can have a completely scalable Horizon environment that you can service to all of your customers. You connect that to your on-premises location through a VPN or through HCX. And now you have a gateway into your on-premises environment through Horizon using any sort of security mechanisms you want to employ at the cloud level. So on that same vein, another option or another solution or use case that we see a lot is application modernization as they slowly migrate into VMC and AWS. So what this means is that a lot of times it's difficult to just, and in this case, we're talking about modernizing your applications from a perspective of breaking out those virtual machines into microservices or containers and running them in some sort of container orchestration service like Kubernetes. So a lot of times, if you're going a bare metal route, that is very difficult to do to run containers alongside your virtual machines. So what VMware is doing and what the vSphere platform allows you to do is run your virtual machines in tandem with your containerized workloads using vSphere with Tanzu. And that gives you the ability to either slowly migrate your virtual machines into a microservice architecture in containers, or have them run side by side for the longevity of their applications and go that route through attrition. So you can use VMC as the test bed to start that process. So if you don't have the resources on premises today and you are not in the business of acquiring new hardware and you're looking to, if your goal is to modernize your applications or write them in a way that is more efficient for the cloud, it doesn't always make a lot of sense to go ahead and buy more hardware just to facilitate that end goal. So what you can do is purchase, VMC and AWS for the length of time it takes you to migrate your applications into that containerized format. And then you can use that platform for that exact purpose and then migrate them natively into the cloud or whatever your end goal is at that point. The last level here, the last solution I have here is the data center extension. And this is more or less the hybrid cloud environment. So what this is kind of tailored for is customers that have issues perhaps with data locality, where some applications need to be on premises and closer to their users. This could be a situation where you have a huge investment within your on-premises data centers. Maybe you have several across the world or the globe. but you want to have some sort of ability to burst into a cloud environment without having to worry about refactoring your applications. So VMC on AWS can be your extension to your on-premises environment from a burst capability, as well as something like a disaster recovery capability. So that can be in an instance where you have a hot standby location, where you have a VMC on AWS software-defined data center built out, all ready to go. In that case, you can still use tools that you're used to using within VMware, such as Site Reliability Manager and vSphere Replication, to have an RPO and RTO of about 5 minutes if your on-premises environment fails. You can use that VMC instance as that hot site for your disaster recovery solution. And again, you're using those same tools that you're already used to today. You're using SRM, using vSphere Replication, and the VMC instance essentially just becomes a colo that you don't have to actually manage yourself. On that same note, there's another solution with VMware Disaster Recovery as a Service that we can talk into in a bit. And essentially what that's doing is making a warm site available for you to back up your virtual machines. And then at the time of of your on-premises site failure, at the actual time of disaster, it'll go ahead and automate the creation of an SCDC in VMC and AWS and attach your workloads to that cluster. The RTO RPO for that is a little bit longer because it is going to automatically build that SCDC, which takes a few hours. But the case remains is that it's a great solution that you can use this as a soft colo or a soft disaster recovery site in AWS without having to worry about any physical equipment or worry about managing the physical equipment during the time of disaster recovery. Okay, so with that, those are the few solutions we're going to talk about that I just want to throw out there is just give some ideas of how this solution can be used. And the solution we're going to look at here is kind of a mix between data center extension and data center migration. And let me just jump into that environment. So what I have here, and right now, so what I'm logged into in this screen, you should be seeing my VMware Cloud Foundation on VxRail environment. So I have two vCenters here, a management domain and a workload domain. These are all managed by an SCDC manager. And I can see that I have, all my clusters, my virtual machines, all that good stuff set up. And we can see what we're going to do here is I'm going to take one of my virtual machines, this tiny Linux virtual machine. It's very small, so it migrates quite quickly. That's located on one of my NSXT segments. And I'm actually just going to throw that into the cloud. And so I'm going to show what that looks like to actually get this machine from my on-premises environment in Sioux City into my AWS environment located in Virginia. If you look at that AWS environment, now I'm looking at my vCenter that's located in AWS. It looks very similar. So if this is something that this is a complete VCF or a complete software-defined data center located in the cloud. So any sort of management tools you had previously, any sort of methodologies for planning changes or any tool sets you had will still work in this environment just as you'd expect. It's just a vCenter located somewhere else that's managed by AWS as well as VMware in tandem. So I'm going to look from here and I'm going to look at my HCX environment. So in this environment, I've deployed HCX, and what that's essentially is doing is connecting my two sites. So I have two sites. I have my on-premises site and I have my VMC environment. So my data center here and I have my VMC environment. HCX is what's bridging those two sites together. So we see that I do have a site pairing here. I have a site pairing between my on-premises and my VMC environment using HCX. And I can see within this, it's deployed what's called a service mesh. And that's going to basically build out all of the infrastructure required to facilitate migrating workloads to and from, as well as doing things like WAN optimization, network extension, cloud migration services, and other services that are required for a clean bridge from my on-premise environment into AWS. So here's my service mesh. We can see it's built out with all the service. So we have my hybrid connect, which is actually the physical connection between the two sites. My WAN optimization that's just used to ensure that the traffic that's sent to and from is going to be queued correctly. Cross-cloud vMotion migration service. This is what we're going to be using to actually vMotion that tiny virtual machine into AWS in sort of a hitless fashion. I have my network extension service, and this is actually taking the subnet or the segment that my virtual machine is located, and it's actually extending it into VMC on AWS so that when I migrate this VM, I actually don't have to change the IP address or the gateway or anything like that. Bulk migration service is what we've talked about a little bit previously. This is another way of migrating virtual machines into AWS if you're more comfortable with taking an outage. So this would be kind of like a a cold migration into the cloud where you can schedule hundreds of virtual machines to migrate into the cloud overnight, or when there's the most downtime available. We have disaster recovery service, and we have the replication assisted vMotion migration service. This is the same thing as the vMotion service. Essentially, what this is doing is going to queue up and allow you to schedule those vMotion migrations, so you can have the data of the virtual machine waiting on the other end. Because if you're trying to migrate, a 100, 200, 300, 400, 500 gig machine into the cloud, that could take some time. So VMware replication assisted vMotion could help with that actual time delay from switching over the VM from on-prem into the cloud. So we'll take a look at, we have these network extensions set up. So this is that part that I was referring to that is actually extending one of my segments. So we can see here that I have this 10.150.144.0 subnet on a segment on-prem that is actually extended into VMC and AWS. We can see the appliance it's using to actually migrate or extend that in there. And we can see what it looks like from each perspective. So if we look at my on-prem environment, we can see this is the name of the segment, and this is where my virtual machine is actually located. And then if we look at the VMC environment on in the cloud, we can see that it created one on my behalf, layer 2 extension, and it gave it the same name as my on-prem segment. So now we know that this subnet at least exists at both sites. So when I migrate this virtual machine, I know that I'll still have reachability to it. And before I go ahead and actually migrate it, I wanted to show just a different perspective of my VMC environment. So what we're looking at now is my VMware Cloud Services console. So this is a console you'll use to access any sort of VMC or VMware services located in the cloud. You'll be able to see what's available to you. You can see here I have a few trials and I have my VMware Cloud on AWS. And there's also this other option that I talked about earlier, that VMware Cloud DR. That we can talk about. But so if I click on my VMC on AWS environment, what I can see here is this is acting like the overall orchestration level for all of my SCDCs in the cloud. So the SCDC that we looked at just a bit ago in the cloud, that's my vCenter, and that vCenter is actually being managed and orchestrated by my cloud console. So I can see here in my SCDCs, once this loads up, that I have my SCDC. You can see the resources that I have associated with that. If I needed to add clusters or add hosts or remove it or whatever, all that is just a self-service click away from adding more compute or more storage to my environment. And also from here, if I wanted to view my details, I can take a look at what I can configure from the cloud console. So with VMC and AWS, you don't have direct access into NSXT or your network fabric. So you'll be using your cloud manager to go ahead and facilitate that. We can see a quick little diagram of the connections that I have of my on-prem environment or my VMC environment to the internet, and my VMC environment into my AWS VPC. And this is kind of what I was referring to earlier, is that ability to run workloads in VMC and AWS and have a fast and efficient connection directly into your AWS services if you consume any of those. If you go look at segments, these are going to be the actual network connections that are built in my VMC environment. And we can see this is that extended virtual machine, or that extended layer 2 segment that we have into our VMC environment. So this object was actually built by HCX. I didn't actually come in here and build that. We can see that it moves the subnet gateway over here as well. And all of that's handled on my behalf through HCX. We can see we're able to build other services here, VPN, we can do NAT services, T1 gateways. If you're familiar with NSXT, this is our routed architecture where all of those segments are actually connected. So this is kind of like our ingress or egress router, the direct next hop for those segments. We also have Transit Connect, which is for, it utilizes AWS Transit Gateway on the back end. This is actually managed by VMware. This is just a way to mesh together multiple SCDC environments. If you have a sprawling cloud environment and incorporating on-premises environment as well, this is just a way to kind of tie all of those things together and provide the glue between them. We also have our security aspects here. So if you're familiar with NSXT, they kind of break up security into east-west firewalling, which is our distributed firewall, which is basically placing a firewall at the VM NIC of all of our virtual machines, similar to a security gateway in AWS. And we also have our gateway firewall, which is going to handle all of our north-south traffic. And this is similar to something like the network ACL within AWS as well. And there's several other options that we can do here. We configure our direct connect capabilities into our on-prem environments. And we can also connect into more AWS VPCs using that Transit Connect. So with that, I'll jump back over to my HCX environment, and I have a ping going to this IP address. This is the IP of the virtual machine that I'm actually going to move over. And so what we're going to do here is we're actually going to migrate this virtual machine into my AWS environment. We're going to monitor the pings to see, it will lose a few as it is actually transitioning the state of the virtual machine into AWS. But we'll go ahead and kick that off now. So to actually migrate virtual machines, in this instance, I'm using this as a use case of, I'm migrating my virtual machines into AWS. Perhaps this can be a permanent movement, or this can be, just a temporary thing. Say maybe my tiny Linux just got too overwhelmed and I had to, get more resources for it. So I'm sending it over to the cloud to consume some of those compute resources. So what I'm doing here is I'm just basically building out the landing zone for this virtual machine. So where is it going to live when I'm actually connected, when it's moving into VMC and AWS? So you can see that up here, the source is my Sterling HCX environment, which is my on-premises VCF, and the destination is my actual VMC cloud environment. So this is pulling in information from my SDDC cloud. So these are all folders and resources groups that are built from VMC and AWS, and just go through and select these. Here's where we have our option for migration profile. So I can vMotion it, replicate an assisted vMotion, and we saw the different services within the service mesh to facilitate those, as well as bulk migration. So over here, we're going to do a vMotion. And essentially what this is going to do is we can see here from my network adapter perspective, this is going to maintain the exact same MAC address that my virtual machine has today. So I don't have to worry about that changing because it will retain the same IP address. And it's actually going to move me from my on-premises segment over to my VMC layer 2 extended segment that's built out by HCX. So I'll go ahead and validate this and hopefully it works. Okay, perfect. And I'll go ahead and start this migration. This is a smaller virtual machine, so it doesn't take too long, maybe a few minutes. But we can go ahead and monitor how that's working here. And while that's going, we'll start seeing different logs and things like that jump out in our VMC environment as it starts to create the infrastructure to facilitate this VM. We can say I still have ping access to it. So it's still, it hasn't moved yet. It's still going through and building out the structure of it and understanding what's going to be migrated. So if we take a look over here, this is my VMC environment. So nothing has been done over here yet. It's still going to kick off that vMotion. But I wanted to point out these two different hosts here. And this is the same on both my environments, my VMC on AWS environment, as well as my VCF on-premises environment. So we can see this host down here that isn't really part of this cluster. And it's not really sure what it is. And what this actually is this is our HCX connection point. So that hybrid cloud services, it actually makes itself look as if it's another transport node or ESXi node within my environment. And this is located on both sides. So if I go and take a look at my on-prem environment, I should have a similar kind of a stranded ESXi host out here. And what this host actually is my interconnect virtual machine from HCX. You can see this is the same IP address. And this acts as the onboarding and offloading of virtual machines as they migrate across. So as my vMotion, my VM is actually vMotioning across, we'll actually see it live on this host for a bit as it goes ahead and finishes the replication of services across. And once it goes ahead and does that, it's going to then migrate this off of this, this temporary host into my actual cluster based on the different components that I set up. So we should see it start populating here in just a moment. So I'll just go back over here and take a look at and see if there's any, hopefully there's no errors in it just yet. Okay, so it's still kind of going across, and sometimes it does take a little bit to just initiate. And this VM again is super small. So this is going to be a use case. I doubt that anybody's going to have a 1 gig VM with 48 gigs of RAM. So, keep in mind the times it's taking to do this. It is still transferring internet over the internet, or transferring information over the internet in this case. And so we can see I'm on my VMC side, and we can see that VMC side is now starting to build out the different folders and architecture to support my tiny migration. And now we see that this tiny migration VM is located on this temporary host in VMC. And so right now we should start seeing that host actually kick off and relocate into the VMC environment. So at this point, the host is still live. The host is still responding from a state perspective from my on-premises environment. You can see the latency is quite low. Once it moves over, we'll see this latency move up because where I'm pinging this from is through a VPN. And so we should see that rise a little bit. And there will be a few drops, but we can see that it acts just like a normal vMotion as you'd expect. If you're familiar with cross vCenter vMotions, which is now built into vCenter 7. This is it looks very similar to that. The difference being that this is facilitated through HCX. And because I'm using that network extension capability, I don't have to change the IP address or anything like that. But if you were in the capability of using this as a disaster recovery solution and you didn't use HCX to extend layer 2, or you didn't use NSX to extend layer 2, or that's something you didn't want to do, you can also use, like I said, SRM. SRM can connect into both of your vCenters at your protected site as well as your destination site. And you would use that just as you normally would in building out your playbooks, building out your your run books for your disaster recovery. Let's make sure I didn't miss this. Okay. So now, while I was droning on there, we saw that my tiny machine actually migrated over to VMC. I dropped 2 pings from it. So that's not too bad considering I'm moving it from Sioux City VCF into Virginia. And now my latency is a little bit higher. And this is simply because my laptop that I'm pinging it from it's actually on a VPN connected to our SCDC. And then again, through another VPN through HCX connected to Virginia. So it's taking a few extra hops, but yeah, we can see that this was migrated across. We only lost a few pings, and now that virtual machine is located in our VMC environment. So again, based on the use case, this could have been a situation where this virtual machine needed more resources that I couldn't provide on-prem. This could be a use case where my plan is to migrate this into AWS as an end goal, and this is just the first step of that. And whatever necessary use case you find, this just gives you another platform to use and build out a completely software-defined data center in AWS, where you can offload a lot of that management. And if we wanted to, because this is a VMware environment, and say you wanted to bring it back, you can easily just bring it back by going here, doing a reverse migration, and bringing it right back, because formats aren't changed. You don't have to worry about a one-way directional type of flow. Okay, and with that, I will leave you with just a quick summary. The goal here is that most industries or most companies or most agencies are not in the business of managing hardware. That's not where you make your value add, is not managing the hardware, not managing the servers themselves. Your value add is brought by managing the applications that actually help out either your customers, the warfighter, whoever that is. That's where your value is brought. So what this solution is really doing is allowing you to focus on just that. You can no longer focus on, what version of NIC driver you have in your thing, or if you have capacity and all that good stuff. Offload all that capability so you can focus on your applications. That's the overall intention of this design and the solution. So I appreciate everybody sticking around. If there's any questions, we can field those now. If not, I want to thank everybody for joining. Mindy, are there any questions, or are we all good to go?
Oh, sorry about that, Billy. I was talking, but on mute. So I do have a couple questions for you, and for anyone else, please use the Q&A feature at the bottom of the screen to submit them. Our first question: does VMware have a solution for disaster recovery that doesn't involve standing up a constant software-defined data center?
Yes, of course. And I referred to that earlier. It is literally called VMware Cloud Disaster Recovery. So it's pretty, I think, named intuitively. And you'll find this in our VMware Cloud services. I don't have that specific enabled, but let me go back here. Essentially what it is everything that we just looked at is the end result. We looked at the SCDC being built. We looked at our migration across, everything being built and pre-staged. That is a use case. If your necessary RPO, RTO, or your time to recovery is less than 5 minutes, you can see that I migrated that VM pretty quickly. So if there was an issue, I can use tools to pre-migrate that machine, essentially using vMotion with SRM and all that good stuff. If I have less of a requirement for recovery times, so for example, if I needed to sorry, I'm kind of stuck in here. If I needed to go ahead and I'm just going to bring this back up. If I needed to go ahead and I had about a 4 or 5 hour time in between a disaster that I need to have my services back up, VMware Cloud Disaster Recovery Service is going to go ahead and basically let it light up a, not necessarily a pilot light, but it's going to use the Datrium scale out file system for you to replicate all of your data into an NFS store in AWS. So you're not paying for the SDDC host to be running all the time. You're just paying for the storage that it takes to actually store your data in AWS. And then at the time of failure, it'll automate the creation of an SDDC environment. And once it automates that creation of an SDDC environment, it's going to take that NFS scale out file system and mount it to the SDDC environment. So then you have access to all those virtual machines running in the cloud. So that solution is great for anybody who's trying to get out of managing a colo or trying to figure out how to, like I need to have a disaster recovery site, but we only have a closet down the street, but we don't want to buy, all the same equipment that we do in our data center. That's a solution for you. I mean, that's something that is very easy to set up. You just kind of set it and forget it. And then once you have a disaster failover, you'll be very thankful that you have it kind of situation.
Thanks, Billy. One other question came in asking if you will receive the link to the recording. Yes, we are happy to send that out to you. And then the other question I have here is, what are the network options for connecting our on-prem environment to VMC on AWS?
Yeah, so there's quite a few. I mean, there are any connection that you have natively into AWS will be essentially supported into a VMC environment. VMC is built on top of a AWS VPC. So you still have the ability to use Direct Connect if you have a high throughput environment and you need something like 40 or 100 gig interconnectivity directly into your SDDC for a true hybrid cloud environment. You can go that route. You can also go a normal VPN route where you build a VPN from a customer gateway device into VMC and AWS, and that will be managed not through AWS directly. It'll be managed again through your VMC console. Also, you have the ability to jump into that Transit Connect that we talked about earlier. And Transit Connect from a VMC perspective is essentially deploying a managed Amazon Transit Gateway. And that gives you kind of the ability to have a hub gateway into the VMC environment, or the AWS environment rather, that you can use to jump off to different SCDCs or different VPCs within AWS. Or you can use HCX like we just did today, that kind of abstracts all of that and creates tunnels between appliances in your environment.
Thanks so much, Billy. For everybody on the slide right now is the contact information if you have further questions in regards to what was presented today. Just a shout out to Billy, Nathan, our cloud team does an amazing job on all of these demos. We actually hold a Power Block session every Wednesday of the week, so please go out, register to join us tomorrow. You can find the schedule of our events at sterling.com/calendar, and we hold those every Wednesday, and then we hold a demo on the second and fourth Tuesday of every month. So please join us. Thank you again, everyone.
Awesome. Thank you.